So the first video for chapter 10 is going to be a quick introduction to momentum, and this is going to cover chapters 10-1 and 10-2. Okay, so we're going to need another conservation principle. So we just finished talking about work and conservation of energy and the work energy principle, and we found that it's incredibly useful for analyzing moving objects. But remember, work and energy are both scalars, right? And this is part of what made them so nice to work with, because we didn't have to worry about the direction. But if you want to know something about the direction, then work and energy are not going to be helpful, since they're scalars and they have no direction information. So it would be nice if we had a vector quantity that was also conserved. And of course, just like anything, there's going to be certain stipulations on when this gets conserved. So what we need is something called linear momentum, or typically we just refer to it as momentum. So the linear part, well, eventually we're going to have something called angular momentum also. But for now, we'll just call it momentum. Okay, so linear momentum. So defined, so we use the letter P, naturally, for linear momentum. It is a vector, and linear momentum is defined as the mass of an object times its velocity. So it's a vector, and since it's based on the velocity, the direction of momentum is exactly the same as the direction of the velocity. And units, well, it's mass times velocity, so the SI units are going to be kilograms times meters divided by seconds. So, using momentum, we can actually write Newton's second law in a more general form using the momentum. Well, and what the more general form of Newton's second law says that the rate of change of momentum of an object is equal to the net force applied to it. So instead of in terms of mass and acceleration, we write this as in terms of the change in momentum. So the net force on an object is equal to the rate of change of the momentum. So dp dt, the derivative of the momentum with respect to time. So, and this is actually more general because the previous version of Newton's second law we had that net force was equal to mass times the acceleration of the object. There was actually an assumption in there that the mass was constant. So the earlier form of Newton's second law doesn't work if the mass is changing, but the version with momentum does.